Imagine a world where seeing is no longer believing, a world where anyone can be made to say anything, their words and actions manipulated with astonishing realism. This is the world of deepfakes, a rapidly evolving technology blurring the lines between reality and fabrication. Deepfakes are videos, audio recordings, or images altered using artificial intelligence to depict someone doing or saying something they never actually did. The term deepfake is a portmanteau of deep learning and fake. Deep learning involves training artificial neural networks on vast amounts of data to learn patterns and make predictions. One of the key technologies behind deepfakes is the Generative Adversarial Network, or GAN. Imagine two AI algorithms locked in a creative duel. The generator creates fake content while the discriminator tries to distinguish the real from the fake. This back and forth continues until the generator produces outputs nearly indistinguishable from real life. Deepfakes hold immense potential for entertainment, education, and art, but their ability to deceive also presents profound ethical challenges. At the heart of deepfakes lies the magic of deep learning, a powerful form of AI that enables machines to learn from data in ways that mimic the human brain. Imagine feeding a computer a massive data set of images, say thousands upon thousands of faces. With each image, the computer begins to recognize patterns, identifying subtle nuances in facial features, expressions, and even lighting. A GAN consists of two competing neural networks, the generator and the discriminator. The generator acts like a counterfeiter, attempting to create realistic-looking fakes based on the data it has been trained on. The discriminator plays the role of the detective, evaluating the generator's creations and trying to spot the fakes. This process of creation and detection repeats over and over again. With each iteration, the generator learns from its mistakes, becoming increasingly sophisticated in its forgeries, while the discriminator becomes more adept at spotting inconsistencies. This adversarial process continues until the generator produces outputs that can fool even the most discerning eye. Autoencoders, another key technique, can swap faces or manipulate expressions by compressing and decompressing images while preserving their essential features. By training separate autoencoders on the faces of two different individuals, it becomes possible to superimpose the features of one person onto the movements and expressions of another. Creating a convincing deepfake often requires significant computing power and technical expertise, but the basic process can be broken down into straightforward steps. Imagine using a fictional deepfake app called FaceGenie. Here's how it might work. Step 1. Data collection. FaceGenie needs images or videos of both the source, the person whose likeness you want to use, and the target, the person you want to manipulate. The more data, the better the results. Step 2. Model training. FaceGenie uses this data to train its deep learning algorithms, feeding them countless images of the source and target to learn the unique characteristics of each face. Step 3. Face swap. With the models trained, FaceGenie performs the face swap, identifying key facial features in both the source and target images and seamlessly blending the two. Step 4. Refinement. The initial face swap might still have imperfections. FaceGenie refines the deepfake, smoothing out rough edges and ensuring that the lighting and shadows look natural. Step 5. Output. Finally, FaceGenie generates the finished deepfake, ready to be shared with the world. The rise of deepfakes has ignited a firestorm of ethical debate, raising profound questions about truth, trust, and the very nature of reality. While the technology itself is neutral, its potential for misuse is undeniable, posing significant risks to individuals, institutions, and society. One of the most pressing concerns is the potential for deepfakes to fuel misinformation and manipulate public opinion. Imagine fabricated videos of politicians making inflammatory remarks going viral, eroding public trust and undermining democratic processes. Deepfakes also pose a grave threat to individual privacy and reputation, amplifying the potential for blackmail, harassment, and revenge porn. Researchers are developing sophisticated algorithms to detect deepfakes by analyzing videos for subtle inconsistencies, such as unnatural blinking patterns or lighting anomalies. As deepfake technology evolves at a breakneck pace, we find ourselves at a critical juncture. The ability to distinguish reality from fabrication has never been more important. Navigating this brave new world requires a collective effort, emphasizing awareness, education, and skepticism. We must become more discerning consumers of information. It's no longer enough to simply believe what we see or hear. We need to question the source of information, consider its potential biases, and be wary of content that seems too sensational to be true. Educating ourselves about deep fakes is paramount. By understanding how these technologies work, their limitations and the telltale signs of a fake, we can become more discerning viewers and listeners. We must work together to ensure that deepfakes, while a powerful testament to human ingenuity, do not erode the very foundations of trust upon which our societies are built.